everyone, in today's video we're looking at another trig function, namely the graph of y equals tan theta. This is the work that you need for exercise 12. Okay, so here's the question format. Again, it says sketch the graph y equals tan theta for theta between 0 and 360. So once again, the question looks very similar. The only thing is, the tan graph is a bit different to the sine and cos graphs, which is why in the table below you can see I've used quite a few more points than I would have used in the sine and cos graph, just to make sure we get the right shape. So I've plugged in a few values of theta into y equals tan theta equation and filled in the table, plotted the points. The only thing is, you can see for some of the points, for example, when theta is equal to 90, then y equals tan theta is actually undefined. The same for theta equals 270. Don't stress about that, it just means that there are no points for y equals tan 90 and y equals tan 270, which is why I have those dotted lines there, and we'll discuss that a bit more later. So the next step, once we've plotted all the points, is to fill in our shapes of the graphs, and we remember to use a smooth curve to do this. So let's just look at this graph, connect the points like that. Okay, so this is the general shape of tan graphs then. You can see it's a little bit different to the sine and cos graph. It's not exactly the waves that we're used to, but still got that curvy shape, and we're going to discuss it now and interpret the graph in step 2. Okay, so step 2, as always, we use the graph to interpret. So the domain of this graph, we saw in the question theta was between 0 and 360. So usually we would say that's our domain. So again, we say, okay, theta is an element of 0 to 360. But there is a slight catch here, because as you can see, we can't really have values of theta at 90 because it's undefined there, and we can't have values of theta when it's 270, also again undefined. So we add a slight little addition onto our domain, and we say theta is not equal to 90 and theta is not equal to 270 degrees. We know from before that the range is the set of all possible y values. If we look at this graph, actually, the y values will increase all the way along up that way, so they go up to positive infinity, hypothetically, and all the way down that way. So we actually say that the y values is y is an element of R. So basically, y could be any real value, any real number. Okay, so the next two components we can read from a tan graph are the x-intercepts and the y-intercepts. I'm just going to quickly circle these here because I'm sure you know how to read them off the graph. So the x-intercepts we can see on this graph is here, here, and here. So you would basically just read off those values and write them here for your x-intercept. And your y-intercept, we see once again it only intercepts the y-axis at 0, 0, so you would write that one down here. The next component we can look at with these sorts of graphs is the amplitude. Now, the amplitude we defined last time as being the height above the x-axis, so it's the height between the x-axis and the wave, like that. Of course, it's a little bit difficult to do that here because this graph just stretches all the way on up, so there's no real amplitude. So for tan graphs, we sort of just ignore the amplitude. That's not something that we need for a tan graph, so we can ignore that. The next components we can read from a graph like this are the asymptotes. Okay, so we already discussed we don't get any amplitudes in the y equals tan theta graph, but we do get asymptotes. So when we were plotting the graph earlier, we found that at y equals tan 90 and y equals tan 270, the graph of tan is undefined. So at these points where it's undefined, we get asymptotes. So all you need to know is that an asymptote is a vertical line where y equals tan theta is undefined. In this case, the asymptote is at y equals tan 90, we've got an asymptote along this line, and again at y equals tan 270. A useful way of remembering this is to look at sine theta over cos theta. Okay, so if we look at this formula below, what we actually get, which is quite interesting, is when we simplify, we find that sine theta over cos theta is actually equal to tan theta. This is quite a useful way of finding out where the asymptotes are. So if tan theta is equal to sine theta over cos theta, it means that when sine theta is equal to 0, for example here, then tan theta is also equal to 0, which we can see. So when we use sine of 0, we get 0, so that's over here, and we see that tan theta is also equal to 0. On the other hand, when cos theta is equal to 0, we get tan theta is undefined, which makes sense again. For example, if we have cos of 90, we're going to get 0, and at tan of 90, we get an undefined. Okay, so that's just a useful way of remembering the asymptotes for the tan graph. All you really need to know is that there are vertical lines for which y equals tan theta is undefined. The last component of the tan graph that we need to interpret is the period. Now, in previous examples with sine and cos, we had a wave that looked something like this, and the period was simply that length of the wave. In this case, we have a slightly different wave because it looks something like this instead. The same principle applies. We try and find a start point for the wave, say somewhere here, and an end point for the wave, and we say that the period is the distance between the start and the end of the wave. If we look at our actual graph, the start point we could say is somewhere here, the end point is somewhere here, somewhere there, and that means the period is the distance between these two asymptotes. Okay, so that's one way of remembering the period for the tan graph. It is the distance between two vertical asymptotes. Okay, in this case we go from 90 degrees to 270 degrees, so our period is 180 degrees for this graph. Okay, so that's a basic introduction to the y equals tan theta graph. I'll be doing some more videos with different examples, more complex examples using the tan graph. If you have any questions, please let me know.